Hello, Algebra 2ers. So today we are going to start a unit about rational expressions. So you need just basically your notes. We're going to take some examples today on what it means to simplify rational expressions. Calculator is always handy as well as something to write with, okay? Let's talk about our big goal today. Our goal is to learn how to simplify rational expressions accurately. So what does that mean? Well, let's first start with what it means to be a rational expression. What are we talking about? If we're going to simplify these things, it's kind of helpful to know what they look like, right? Well, a rational expression is just a fraction, also known as a ratio. Okay, it's just a fraction we're going to simplify. The trick is those fractions, well, they contain polynomials. So we have a ratio of polynomials. What's a polynomial? Those are those big things with lots of terms in them, right? X to the fourths, x to the thirds, all of that stuff. They're going to be now made into a fraction. So how do we simplify them? We need to understand some basic things. We need to understand how simplifying of fractions really work, because basically we're going to be looking at a lot of fractions. We're going to need to remember how to correctly cancel or reduce fractions. And of course, factoring comes into play. How we factor is going to help us simplify these things. So let's take a step back to your earlier years of understanding fractions and how we simplify them. First of all, it would be incorrect to take the fraction 10/12 and factor it in your own creative way. Now you know and I know that when you simplify fractions, you divide something common out of the top and bottom. Well, why is that? Here's why. It's incorrect to simplify fractions by dividing them up into things that are basically adding. Like 7 plus 3 is in fact 10. This is true. 7 plus 3 is 10, and 9 plus 3 is 12. But you cannot now cancel off these threes. That is not legal. Whoops, that is not legal, because then you would get an answer of 7 nines, right? Like that's what would happen. We need to be careful to understand how we simplify fractions. We basically need to think about them canceling factors. This is a no-go on this. Canceling factors, not terms. So for example, if we divide 10 into what is 5 times 2, and we also take a look at 12 as 6 times 2, then I can say, oh yeah, if I divide a 2 out of both the top and the bottom, it becomes 5/6. That is the correct answer for 10/12. It's understanding that you're dividing out something top and bottom, and that means you must have multiplication on the top and bottom. So let's try some examples that'll look a little complicated here, but we'll break them down easy so that we can understand what's happening when we simplify. When you simplify things that look like this, you cannot just start crossing off random stuff to cancel or to simplify. You need to first factor the numerator and the denominator, the top and the bottom. Factor so that you turn it into multiplication. Right now we have 40x plus 20. This is addition all day, people. Addition does not simplify with division. So we first need to change the way the top part of this fraction looks. We need to factor. Is there something common I could take out of both of those terms? Well, sure, a 20. And if I divide that 20 out, it becomes 2x plus 1, right? Now, what if I were to divide out something common on the bottom? Well, like a 10, right? Then we would have x plus 3. Now I've just factored the top and the bottom, but in doing so, I've made multiplication happen. This is 20 times that factor. This is 10 times that factor. So now I can simplify through division. I can take this 20 divided by that 10 and turn it into 2 over 1. So this becomes 2 over 1. X or 2x plus 1 is still in here, right? And x plus 3 is still in here. We cannot simplify any further than this. This is as simple as it gets in terms of simplifying that fraction. Let's take another look at one. Here's another guy right here. We need to simplify this fraction, but first we must factor it to see what cancels away or see what divides off. So is there something common I could divide out of these first two things here? 2x, right? And that would leave me with x plus 4. And on the bottom, I have 12x. Notice that that's all multiplication. There's no adding, subtracting, no other terms there. So there's nothing for me to do. Now, all I need to do now is look at what I have and see if now I can simplify. This 2x over that 12x, I can now divide 2x out of both the top and the bottom, or I can now simplify, making this become 1/6. That's what 2 over 12 becomes, right? And x over x can cancel off, leaving me with x plus 4 in the numerator all by himself, okay? So this is the simplified version of that crazy fraction. Now they do get a little bit more complicated when you look at stuff that looks like this. But again, we still need to factor. Let's look at the top. This is 2 terms. Is there something common I can divide out of those 2 terms? Sure, 2x, right? Leaving me with x plus 5. Now if I look at the denominator, the bottom part of this fraction, this has 3 terms. I need to do the AC method to this guy. 3 times 5 is 15. What multiplies to make 15 and adds to make 16? 15 and 1, so I'll do 3x squared plus 15x plus 1x plus 5. This is just factoring like we always do. Take out the 3x here, it leaves me with x plus 5. Take out the 1, leaves me with x plus 5. So my factors in the denominator or on the bottom of this fraction are the x plus 5 and the 3x plus 1. Now that I've factored it all or turned it into the multiplication problems I needed, now I can simplify the factors. Notice that the numerator and the denominator both have that x plus 5 as a factor. Whoosh! Whoosh! I can divide the x plus 5 off of both the numerator and the denominator, leaving me with 2, ooh, that got a little crazy there, 2x over 3x plus 1. Can I simplify it any further than that? That would be a no. This is it. You cannot cross off x's with x's, regular numbers with regular numbers here, guys. We can only cancel factors, and that's only after we've done the factoring itself. Okay, last one here. Let's take a look at this guy. Simplifying this rational expression, I need to factor the top. This is x squared minus 49. That's a difference of perfect squares. So that becomes x plus 7, x minus 7. But the denominator here, ooh, that looks a little yucky, right? Notice they're all divisible by 2. Do you see that? So I'm going to divide a 2 out there. And it's going to become x squared minus 2x minus 35. And now I need to factor that. 1 times negative 35 is negative 35. What multiplies to make negative 35 and adds to make negative 2? Negative 7 and 5. So my 2 that I have on the bottom that I took out is still there. But now it becomes x squared minus 7x plus 5x minus 35. And I'll group, pulling out an x, leaving me with x minus 7. Pulling out a 5, leaving me with x minus 7. So my factors on the bottom become x plus 5 and x minus 7. So x plus 5 and x minus 7 are on the bottom. But don't forget that little 2 guy that we took out right away to make that problem a little smaller. He's sitting out in front still as well. So now that I have it all factored, now I can look to cancel or divide out top and bottom the same factor. So notice how I have an x minus 7 up in the numerator and an x minus 7 in the denominator. I can simplify that, leaving me with an x plus 7 over a 2 and an x plus 5. Okay, this is my simplified answer. That's as far as it goes. Those factors do not cancel with each other. Okay, so this is where we're going, guys. We're going to be simplifying rational expressions. We're going to be factoring and looking to see what we can divide off or cancel away so that we have a simplified fraction. All right, guys, I want to thank you for taking good notes. Kincaid out.